Okay, part 4 of topic 8-2, trigonometric ratios. So this is the last piece of the lesson, and it simply deals with, we're basically taking it back to algebraic expressions with a little bit of a trigonometric twist. So a little background on how this works out. So we'll take it back to the beginning of the lesson, and there's our trusty triangle ABC. Whatever, let's just use black. A, B, C. Not for the right angle though. Lowercase a, B, and see, although really these aren't going to play much of a role here. Not too much anyway. Alright, so we're going to use the complementary relationship of angles A and B to solve some algebraic expressions. Okay, now how does this work out? Well, first we have to remember how sine and cosine of the two angles relate to one another. We'll just use one example. All right, so we're looking at angle A. Let's use sine. So the sine of angle A we know is opposite divided by hypotenuse. Now, which one's the opposite side? Well, angle A is right here. We go across. Opposite is lowercase a. And the hypotenuse, well, is C. So we know that the sine of angle A is lowercase a divided by lowercase c. We move up to angle B. For angle B, let's look at the cosine. The cosine of B is equal to A over C as well, because remember, cosine is adjacent divided by hypotenuse. All right? The sine of an angle is opposite divided by the hypotenuse. The cosine of an angle is adjacent divided by hypotenuse. Okay, so the angle B, well, the opposite would be lowercase b, so the adjacent must be lowercase a. So now we look at these two trigonometric functions, they both equal the same thing. Both of them are equal to the ratio A over C. Therefore, using either substitution or the transitive property, whichever you choose, we can logically conclude that the sine of angle A is equal to the cosine of angle B. Now the thing to be careful with here is that this is not to say that angle A and angle B are congruent. That's not the case at all. What this is telling us is that the sine of angle A is equal to the cosine of angle B. Okay, so once again, this relationship does not necessarily tell us that angle A is equal to angle B. So let's demonstrate. Let's use an example. Let's say measure of angle A is 50 degrees. If I take the sine of 50, 50 sine, we get 0.766044443. But now if I take the cosine of 50, we get 0.64278761. But if sine of A is equal to cosine of B, well, what's going on? Well, like I said, the sine of A and the cosine of B, that doesn't necessarily, because these two are equal, that does not necessarily mean that A and B are congruent. Okay? Now, what do we know about A and B? Well, remember, A and B are your angles of the triangle, your acute angles of the triangle. So what we know about angles A and B is that they are complementary. Right? Because any triangle has an angle sum of 180 degrees. Right? So we know that the measure of angle A plus the measure of angle B plus the measure of angle C must equal 180 degrees. Well, we already know that angle C, in any right triangle, you have at least one 90-degree angle. So A plus B plus 90 degrees is equal to 180. Take away 90 from both sides. Well, 90 is half of 180. So we know that the measure of angle A plus the measure of angle B is 90 degrees. So this is the relationship that we are going to be working with here. A plus B is equal to 90. So if the sine of angle A is equal to the cosine of angle B, what we know is that A and B, these angle measures, will add up to 90. So what does a problem like this look like? Well, let's look at a few examples, beginning on page 21 of the PDF. Okay, so we are on page 21, number 1. Okay, so that one's the top left. So it says the sine of x is equal to the cosine of 55. Now, so if you're too hasty, this is where you're going to make a mistake. Again, we get caught up in the idea that the two sides are equal, and you might say, oh, well, if sine of x equals cosine of 55, well, x must be equal to 55. Awesome, I'm done. Move on. Well, no, that's not right. Again, the sine of angle x is equal to the cosine of 55 degrees. So x is not necessarily equal 55 degrees. This is incorrect. Since one side is sine and the other side is cosine, what we can definitively say is that x and 55 are complementary, meaning they add up to 90 degrees. So again, since we have sine on one side and cosine on the other, what we can say is, well, if I take x and 55 and I add them together, it must equal 90 degrees. So, starting things off pretty simple, so we just subtract 55 from both sides. And x is equal to 90 minus 55. $35 degrees. Pretty simple. And that's how we start off. And then things get a little more exciting as we move through our examples. So let's skip to example number 3. Where you are given the sine of 3x minus 1 is equal to the cosine 17. And again, you don't want to say 3x minus 1 equals 17. Not the case. Since we have sine on one side and if we had sine on both sides, then yes, they would be equal. But since we have sine on the left and cosine on the right, these are not. These will be complementary. So 3x minus 1 plus 17 is equal to 90 degrees. So we combine our like terms. We have negative 1, positive 17. Those are like terms. There's no other variable, so we can't do anything with that. So we now have 3x plus 16 is equal to 90. And I'm running out of space here, so I'll write a little bit smaller. So now we have a two-step equation. Subtract 16 on both sides. 90 minus 16 gives us 74. So 3x is equal to 74. Our final step here is to divide both sides by 3. 74 divided by 3. Let's go up this way over here. And we determine x is equal to 24.6 repeating. Directions say to round to the nearest tenth. Since it's 0.6 repeating, well, we know that this 6 is followed by a bunch of other 6s. 6 is greater than 5, greater than or equal to 5, so we approximate our solution to x is equal to 24.7. And let's do one more example. And we'll work on question 4, page 21. So. That one, you are given cosine x plus 10 is equal to sine 3x plus 20. Cosine on the left, sine on the right, so we know that our expressions here must be complementary. Plus 10 plus 3x plus 20, complementary, they must add up to 90. So now we combine our like terms. Well, let's see. We have x, two x terms. And let's use blue here. And we have two numbers. So the x's are positive, so they add up. Now we have 4x. 10 and 20, both are also positive, so those add up, and we get 30. So we combine our like terms, 4x plus 30 equals 90. So now just a two-step equation. Subtract 30 from both sides, cancel it out. So 4x is equal to 0, 0, 9 minus 3. And finally, we divide both sides by 4. So x equals 15. And that's it. The question is only asking for the value of x, not the measure of the angles themselves. So once we solve for x, we're done. Again, the rest, so that concludes lesson 8-2. Pages 22, 23, and 24 have additional examples. Again, all the answers are provided, so it's just a matter of showing your work. Do you know how to get from point A to point B?